In this video, we're going to take a look at adding and subtracting rational expressions. Now, before we get into rational expressions, let's review how to add and subtract rational numbers. So let's take a look at this first one here. We can see that all the denominators are a 7. And so because they're all 7 already, we can actually just add and subtract without having to do anything. So when we do this, we have 10 minus 5 and then plus 1, which then is going to equal 6. And remember, the denominator always stays the same. So this will be 6 over 7. In our second one, the denominators are different. So we have to get the lowest common denominator in order for us to be able to subtract these two fractions. So that lowest common denominator here is going to be 24. So what I need to do is multiply the first fraction by 3. And then the second fraction, I need to multiply it by 2. So we have 21 over 24 minus 10 over 24. And that's going to give us 11 over 24. All right, in our last fraction subtraction question here, our lowest common denominator is going to be 6. We don't actually have to multiply both together to get lowest common denominator because I can see that 3 actually goes into 6. So here, I only need to multiply the second fraction by 2. So now I have 5 minus 8. Another way to write this instead of having two separate fractions is I can now write one big line all over 6 because the denominators are the same. And then subtract the numerators. So it's negative 3 over 6. And this reduces to negative a half. Now, I didn't write this down, but I could have factored each of the denominators to find my LCD. But because these are just basic numbers here, I was able to figure out what the lowest common denominator is without actually having to factor my denominator. However, when we get to adding and subtracting rational expressions, we will have to be doing some factoring. So let's take a look at how to factor these questions here. Now, if you kind of take a quick glance, you'll notice that all of these actually have the same denominator. So let's simplify the first one here. And I have 5x minus 2, and then I have a minus a 4x plus 1. Now be really careful because when we subtract, we have to remember to distribute that negative sign to both the 4x and also the positive 1. So what you're really doing, let me rewrite this, is you're subtracting 4x plus 1. So everything in the second fraction is going to get subtracted. So when we do this, we get 5x minus 4x to be x, and then negative 2 minus 1 gives me negative 3 all over 3x. Now, you might be thinking, well, I can cancel off the x and cancel off the 3. But remember that only the 3 is separated by the x by a times symbol. However, in the numerator, I have an x minus 3, which is actually a binomial. So this is not multiplied by anything. Unless I see an identical x minus 3 in the denominator, I cannot cancel and I cannot reduce. All right, now one extra thing that I need to do is I should identify what the non-permissible values are. So in this case, we only have one variable in the denominator, and that variable is x. So I know that 3x cannot equal 0. So here we would say that x cannot equal 0. All right, let's take a look at another one. And again, we have 10m minus 1 minus another 8 minus 2m. So I'm going to subtract. This time I'm not going to show you this middle step here. Let's see if we can do it without it. So we have 10m and then minus 8 and also minus negative 2m. So we're going to go 10m minus the negative 2, which will give me 12m. And then negative 1 minus 8 will give me negative 9. And all of this will be divided by 4m minus 3. Now, once we've simplified by subtraction or addition, we always want to check to see if we can simplify any more. So from before, we're going to check by factoring, and we can factor our numerator. So I can take out a 3. So this becomes 3 bracket, or 3 times 4m minus 3 in the numerator. And notice I also have a 4m minus 3 in the denominator. So actually it was great that we factor, because now I can see that the 4m minus 3 is a common binomial factor in the numerator and the denominator. So I'm going to cancel them off. So all I'm left with is just 3. Checking for non-permissible values, we go back to the beginning, and we have 4m minus 3, and that cannot equal 0. So 4m cannot equal 3, so therefore m cannot equal 3 over 4. All right, let's take a look at what happens when the denominators are different, because most likely the denominators are not always going to be the same. All right, so first thing is we are going to factor, if possible. And actually, when I say factor, I really mean factor just your denominator, okay? Now you can factor to the numerator, and then hopefully maybe something will simplify it, but often that doesn't happen. So now we're going to go into the second step, which is to find the common denominator. And this is easiest to use the lowest common denominator. So the LCD must contain the greatest number of any factor that appears in the denominator of all the fractions. So if a factor appears once in any denominator, we include it once. If it appears twice in any denominator, we include it twice, and so on. Now, it's harder to tell or show you this with the numbers or the integer values. So I'm going to show you this when we are taking a look at monomials. And number 3, step 3 is to write equivalent fractions with the LCD, so with the lowest common denominator. And then finally, we're going to add or subtract like we did before, because now the denominator is going to be the same. We can just add and subtract. All right, so we're going to take a look at one here where the denominator is simply just whole numbers, and then we'll take a look at one where the denominator is not whole numbers. So we can see here that the lowest common denominator is going to be 12. So, and that's because 4 goes into 12, and so does 6. I'm going to multiply the first fraction by 3. I'm going to multiply the second fraction by 2. When I do that, I get 15y minus 6. Don't forget this is a plus, so it's going to be plus 2 times 2y, which is 4y, and then 2 times 3, which is 6. And that's going to be all over my common denominator of 12. So I just wrote one big line just to make it simpler, so I don't have to write 2 separate fractions. Simplify by joining like terms. So I have 15y plus 4y, which is 19y. And then negative 6 plus 6 is 0, so I don't need to write that. And that's all divided by 12. Now here, there are no non-permissible values because we don't have any variables in the denominator, so we are done here. All right, our next one, we have some variables in the denominator. So my lowest common denominator, when you're looking for these, we do want to factor first, but here it's actually already factored because they are monomials, so it's a little bit simple. We don't have to do the factoring. So we're going to list our common factors. So if I take a look at the first term, or the first fraction, I have a 5 and I have an x. When I go to the second fraction and look at the denominator, I have a 2 and an x squared. So I don't have a 2 written down in my lowest common denominator, so I need to write the 2. And then I can see that there's an x squared. I have one of the x's already, so I need another x to make it x squared. So now you can say that my lowest common denominator is 10x squared. Now in terms of now multiplying the numerator and the denominator to get the equivalent fraction, I can now see that what's missing from the first fraction is I'm missing a 2 and an x. So I'm going to write this as 2x multiplied on the top and the bottom. In the second fraction, when I look, I have the 2 and the x squared already, but I'm missing a 5. So I need to multiply the top and bottom by 5. So this gives me 14x minus 15, and all of this will be divided by 10x squared. Now I can't simplify because I can't factor my numerator. So now I'm going to look for my non-permissible values. And for both of them, there is an x here. So we know that x cannot be 0 because it's not a binomial, it's just a single monomial, which means that my non-permissible value is just going to be one single value here, which is going to be x can't equal 0. Okay. The last type of question I'm going to show you is what happens when it's a fraction within a fraction. How do we simplify something like this? All right. So when we take a look at this question here, I can see that, I do have a denominator with an x minus 9x, which is not just a single fraction, but within the fraction, the numerator and the denominator, I can see there is an x. So I'm going to say that my lowest common denominator is x. So what I want to do is I want to just join my numerator together and just join my denominator together separately. So I'm going to pretend, or actually I'm going to write a 1 underneath a 3 so I can see that. I need to times the top and the bottom by x. So now I have a common denominator of x in the numerator. So that gives me 3x plus 9 all divided by x. So that's going to be my numerator. Now let me just show you this in a separate color or a different color. So I'm going to write a 1 underneath the first x in the denominator. So again, I need to multiply the top and bottom by x so that I have a common denominator of x. So my denominator, I'll separate this with a different color line, is going to be x times x, which is x squared, minus 9, all divided by x. So this is, the blue is my numerator, and the red is my denominator. Now I'm going to rewrite this in a different way. So I can see actually that the 3x plus 9x is going to be my first fraction. This green line, I'm going to rewrite that as a division symbol. And then I'm going to now write x squared minus 9 as my second fraction. All right, now that I've written it side by side, this actually becomes something that we're familiar with. So I'm going to rewrite the first fraction, change my division to multiplication, and then flip or take the reciprocal of my second fraction. So this is a simple multiplication, which we've done before. So I'm going to factor out a 3 from the first fraction. And I'm going to factor the denominator because it is the difference of squares. Now, even though I have this separated as two fractions, remember that I can also draw one big long line, separate all of these by times symbols, these dots, and then anything that is separated by these dots could be canceled off if it's similar on the numerator and the denominator. So I see that I have an x in the numerator and denominator. I also have an x plus 3 in the numerator and denominator. So the only thing that I have left in the numerator is going to be the 3. In the denominator, I have an x minus 3. Now remember, the 3's can't cancel off because the x minus 3 on the bottom is a binomial expression. And we can't it's not separated by time, so we cannot cancel off the 3. So to finish off, let's find the non-permissible values. And we're going to go back to our original question, which is back up here. And over here, we can see that x cannot be 0, because that was in the denominator. But if we go further down, we also now see that we have a new denominator of x minus 3 and x plus 3. So from here, we can also see that x cannot be plus or minus 3. All right, so I've showed you different types of adding and subtracting rational expression equations, or functions, I should say.